Okay, guys, so this is technically day 2 on multiplying binomials. I mean, last time we multiplied binomials with binomials, binomials with trinomials. We know it's all just a bunch of distributive property and combining like terms, but I do really want to focus on multiplying binomials with binomials, right? So this is the worksheet that you had last time. Hopefully you finished it by now. But let's do a couple of these together. Like some of these are just very straightforward. You want to distribute this into this, right? So there's 2 terms. It's a binomial. That's what I mean by binomial times binomial. You have 1 term, 2 terms. And let's distribute here. We're going to distribute one of these at a time. I'm going to first start with the regular x. So when I say x times x, that is x squared. Okay, so we have x squared. And then x times 4, that is a 4x. Okay, if you're thinking, wait, how did you do that? Well, x times 4, when you write 4x, that just means 4 times x. So it's not like you're changing anything, right? And then we're going to distribute, we already distributed the x, now let's distribute the positive 7. Positive 7 times x is positive 7x, right? And then positive 7 times positive 4, it's a positive 28. And of course, we could combine the middle terms, the 4x with the plus 7x. When you add 4 and 7, you will get 11 of those x's. So that's positive 11x, the x squared in the front with the plus 28 at the back.
Right here, by the way, I got something.
So it gets a little bit more challenging when you actually have a coefficient in front of your variable, right? But it's pretty much just as easy. So when I distribute 2x times 2x, well, you multiply the number 2 times the number 2, the coefficient 2 with the coefficient 2, that'll give you a coefficient of 4. And then when you do x times x, that's x squared, okay? And when you distribute 2x times positive 4, well, the coefficient 2 times the number 4, that's 8. And of course, it has a single x right there. And then distribute the minus 9 times 2x. Minus 9 times a positive 2 is a minus 18, of course, with an x. And a minus 9 times a positive 4, negative times a positive is a negative. 9 times 4 is 36. And like always, on these types of questions, we could most of the time combine the like terms that are in the middle right here. 8 take away 18 is a negative 10 of those x's. 4x squared comes down, and the minus 36 in blue comes down as well. And there's your answer. It's a quadratic trinomial. It's important to note that when you distribute, x times x is x squared. Exponents change. When you're multiplying, exponents change. But when you're combining, where you're saying, I got positive 8x, take away 18x, you don't change exponents. You just add or subtract according to your signs. Is everybody cool with that? Okay. So we really need to get really comfortable with multiplying binomials times binomials, right? So this guy right here, for example, this is how quickly you should be able to do it. A times a squared. A times negative 6, negative 6a. Positive 5 times a, positive 5a. Positive 5 times negative 6, negative 30. Combine the middle terms because they're both a values, they're like terms. You're going to have an a squared minus 1a minus 30. You ultimately have to do it that fast, and of course, without making mistakes. It's not a difficult skill, but you need to master it, right? And the only way to master it is to practice it over and over and over, distributing, right? Is there anyone that you'd like to see from this worksheet? Or should we move on to today's extra practice on this stuff? Extra practice? All right, check it out. What we're going to do, I'm going to give you this worksheet right here, and I'm going to give you 10 minutes. I want to time you 10 minutes and see how far you could get, okay? I don't want you to copy any of these down. As a matter of fact, I want to pause this. I want to pass it out. I want to put it face down, and I want to give you guys 10 minutes to work on it. Then afterwards, I'll explain some of these questions. Okay, so number 1, when you distribute m times m, that is m squared. And then you go m times 1, that's going to be a 1m. And then you already distributed the m. So now let's distribute the positive 4. So positive 4 times m, that's positive 4m. And positive 4 times positive 1 is positive 4. That's distributive property. Exponents do change. You have an exponent of 2 here. You didn't have exponents up here. When you multiply, exponents do change. After distributive property is combining like terms. So you have to combine the 1m with 4 more m's. That's a total of 5 m's. What about the m squared in the front? Bring that down. What about the plus 4 at the back? Bring that down. Could you add m squared with 5m? No, those are different terms. That's like saying I have 1 of these oranges and I got 5 of these apples, right? You can't combine those. They have to be exactly the same, like 1m and 4m. Those are exactly the same. That's how you could add those and get 5m. But you can't add an m squared with an m. You just can't do that. So you're done. That's your answer right there. Does that make sense? Okay, so if you're struggling with this, I would use arrows for sure. I want to do one more example. Of course, we're going to do more, but I just want to go through one more here. Like number 8, if you're struggling, please follow along with me here. We're going to distribute the 2x times x, which really has an invisible 1 in front of it. So 2 times 1, that is 2. So you should write 2 right there. And then x times x, that is x squared. And then distribute it to the other one, 2x times 3. Well, 2 times 3 is 6, and it's positive because positive 2 times positive 3 is positive 6. And what about the x? Well, you just bring it down. Since there was no other x, you're not going to get an x squared or x to the third. You just take that x and bring it down right there on with the 6. So you've distributed the 2x. Now you want to distribute the minus 6. So now go ahead and squiggly underline the minus 6 and then draw an arrow. Negative 6 times 1x. Well, a negative 6 times 1 is negative 6. And of course, the x, you're just going to bring it down as well. And then negative 6 times positive 3, that's a negative 18. So we have distributed. After distributive property, we always try to do combining like terms. We have 1, 2, 3, 4 terms. Out of these 4 terms, you could only combine the ones that are alike. This is an x, that's an x. You could combine them. Like if I had 1x plus 1x, that'd be a total of 2x's. But right here, I have 6x's and I owe 6x's. So if you had $6 and you owe $6, you pay it off, you're not going to have any money left. So there are no x's here in this case on number 8. What do we have as a final answer? 2x squared minus 18. Any particular other questions you'd like to see on this worksheet before I just let you work? Whoops. No? Anybody? Or do I pick one? Which one? Any question you want? Which one do you want to do? Number 4. Okay. Let's go to number 4. Once again, we're going to, you see, we have 2 terms here. It's a binomial. And we want to distribute this one and then that one. So I want to start with t. I'm going to go t times t is t squared. I'm going to use a capital T because then it confuses me. It looks like a plus sign. T times negative 3, that's a negative 3 with the t. And then I go positive 4 times t. Well, that's a positive 4 with the t. And then positive 4 times negative 3, positive times negative is a negative. 4 times 3 is 12. After distributive property, you combine like terms. You have a minus 3t with a plus 4t. Because they both are the same type of values, t's, I owe 3 of these t's, I have 4 of these t's, I'm going to pay off what I owe and I'll still have 1 left over. So positive 1t is what I have left over. And of course, you don't even need to put the plus 1. You could just put plus t. So our answer will be t squared plus t minus 12. T squared plus t minus 12. You want to do another? Yes, please. Okay, let's do another. Number 11? 18. Oh, wait, you guys are getting to... Oh, 18 is a good one because it has different letters. Okay, a lot of people get confused with that. But it's really not confusing at all. When I go x times 2x, well, I'll get a 2 with an x squared. Again, because there's a 1 right there, it's like saying 1 times 2 is 2, and then x times x is x squared. Then we distribute 1x times negative y. Yeah, positive times a negative is a negative, And x times y is exactly that, xy, because xy means x times y. And then now that we've distributed the x, now let's distribute the minus y. So distribute minus y times positive 2x. A negative times a positive is a negative 2, and y times x is yx. But instead of writing it as yx, I want to switch them and put xy. You can put them in order alphabetical. That way it looks exactly like the previous term. And last but not least, negative y times negative y. That is a positive y squared. And the middle terms, right here, you owe one of these xy values, and then you owe two more of those xy values. So if you owe one and you owe two, you're going to owe three altogether of those exact xy values. The exponents don't change when you're adding or subtracting, only when you're multiplying. So the first term, 2x squared, comes down. The last term, plus y squared, comes down. And there's your final answer, 2x squared minus 3xy plus y squared. Okay? Should we do another, or are we good? One more. Okay, let's do one more. Which one? 21. Oh, man, you guys got to the binomials, times trinomials. Okay, I'm going to go through this kind of quickly because I don't like it. K times k squared, k to the third. K times 3k is 3k squared. K times negative 6 is a negative 6 with the k. I've distributed the k. Now I could forget about k for a little while and just distribute the 4. 4 times k squared is positive 4k squared. 4 times 3k is positive 12k. That's it. And 4 times negative 6 is negative 24, no k. So we have 1, 2, 3, 4, 5, 6 terms. Out of those 6 terms, we're going to start with the highest exponent, k to the third. There are no other k to the thirds. So that is the first part of my answer, k to the third. I can't combine it with anything. But then I could move on and combine the positive 3k squared with the positive 4k squared. A positive 3 and a positive 4 added together is a positive 7 of those specific k squared values. And then I move on to my regular k's. I owe 6 k's, but I have 12 k's. I could pay that off. I'll have 6 k's left over. And at the very end, we see that there's a minus 24, and there are no regular numbers like a negative 24 besides this one. So that just comes right down, and that's the final part of my answer, the constant of this cubic polynomial expression. So here's my answer, k cubed plus 7k squared plus 6k minus 24. All right, guys, I'm going to end this video here. Hopefully, you guys could finish it up.